Hello everyone. I'm Kaswa. In this project, I built an end-to-end explainable recommendation system with SHAP-based feature attribution. Okay. The main goal is not just to recommend items, but also to clearly explain why each recommendation is made. Okay. In this video, I will do a short walkthrough. I will explain the architecture, model choice, explanation strategy, evaluation metrics, and final outcomes. Okay, coming to the problem statement, modern recommendation systems often work like black boxes. User gets suggestions but not understand the reason. Okay, this is a trust issue, and it is also becoming a compliance issue under emerging AI regulations. So the core problem I solved is how do we generate high quality recommendations and attach human readable reasons based on user history. Okay. Coming to this system architecture, my pipeline has four main stages. The first one is data preparation. Okay, it is done in prepare data.py file. Okay, and the second one is model training. It is done in train model.py file. And the third one is SHAP explanation generation. Okay, it is done in generate explanation.py file. And explanation quality evaluation, it is done in evaluate explanations.py file. Okay, this flow is the flow is load and process datasets. The second step is split into train and test. The data is split into train data and test data. And the third one is train baseline and matrix factorization models. Okay, and the next process is generate recommendations score for user item pair. Okay, in this, the model generates a recommendation for an user and it is linked to the pair. Okay, and coming to the next step, it will compute SHAP attributions for past interactions. Okay, and the next one is convert top contributors into a natural language explanation. Okay, and the last one is evaluate faithfulness and consistency. It will evaluate the faithfulness and consistency of the explanation. Okay, and in this I containerized everything and runs through Docker Compose. Okay, and coming to the data preparation, I use movie lens data through an automated download path. If download fails, the script falls back to synthetic data, so the project remains runnable. Okay, the script outputs is train.csv, test.csv, usermap.json, and itemmap.json. Okay, I use leave one out splitting per user, so each user has held out interactions for testing recommendation quality. Okay, and coming to the model choice, I implemented two models. First one is baseline popularity recommender, and the second one is matrix factorization collaborative filtering model. Okay, I selected matrix factorization as the advanced model because it captures latent user items preferences better than popularity. It is computationally efficient. It provides item embeddings that can be reused for explanation logic. Okay, I evaluate the model with precision at the rate 10 and ndcg at the rate 10 and save outputs as JSON. Okay, coming to the SHAP explanation strategy, a key challenge is the collaborative filtering usually takes only user ID and item ID, which is not directly feature based for SHAP. So I reframed features as the user's past interacted items. For one target item, feature vector dimensions correspond to historical items. Each feature indicates whether the history item is present or not. A wrapper builds a proxy user representation from selected history items. And then the model score for the target item is computed from the proxy. Then SHAP values estimate each past item's contribution. Finally, I pick top positive contributors and generate a sentence such as, we recommend this because you interacted with item A, item B, and item C strongly align with it. Okay, and coming to the explanation quality metrics, I implemented both required custom metrics. First one is faithfulness. For sample recommendations, removed top 3 SHAP contributor items from user history. Compare score drop against removing 3 random history items. If SHAP removal caused a larger drop, then sample counts as faithful. Okay, and coming to the consistency, build user similarity using cosine similarity for interaction vectors. For simpler user base, explain the same target items. Okay, compare overlap for top 3 contributors using Jagged similarity. Okay, average across pairs for final consistency score. Okay, this validates explanation quality beyond just recommendations accuracy. Okay, coming to the DevOps and reproducibility, the project is fully Dockerized with Docker file, Docker compose.yml, and health checkpoint. Okay, running Docker compose up --build executes the full pipeline and produces required artifacts. I also included .env.example, readme with architecture and model justification, and user study report.md template for finding summary. And coming to the final output, it includes baseline and model performance metrics and SHAP explanation JSON with top contributors and explanation metrics for faithfulness and consistency. The system is end-to-end reproducible, explainable, and aligned with the assignment contracts. This project demonstrates how to move from black box recommendations to transparent, auditable recommendation with practical explanation quality evaluation. Okay. Thank you for watching.